Acceleration time graph is the simplest graph. It does not give us lot of information. If we talk about the slope of acceleration time graph, that would be dA by dt, and that is not a physical quantity, so that does not give us a useful information. If we talk about the area, as we talked about in a previous some of the lectures, that the area under acceleration time graph is nothing but the change in velocity, and that is the only meaningful thing that we get from the acceleration time graph. So now let's take one example on this to understand this thing. So the question states this is the acceleration time graph of a particle moving along a straight line. Initial velocity of the particle was 10 meter per second, and we have to find velocity at the end of 30 seconds. This is the AT graph. Its area will give a change in velocity. Only thing we have to be careful that the area above tx would be positive, below tx would be negative. First, let me calculate the magnitude. So if I talk about this area, so that area will be 10 into 20 by 2, so 100, and the unit meter per second is square into second, so this area will be 100 meter per second. And this time I do not know, but I can get from the similar triangle, but actually I do not need to know that time either. You can see that these two triangles are similar triangle, because this angle 90, this angle 90, this angle equal to this, so this angle is equal to this. So these triangles are similar triangle. So the ratio of this to this and ratio of this to this are same. And this is 20, this is 30, so this is half of this, so this is also half of this, so that would be 5. But I can directly say if these two are the similar triangle, the ratio of these sides are half of that, these sides, so this area will be 1/4 of that, because area is equal to base into height by 2. So this area with sign would be minus 25 meter per second 100 by 4, because as I told that this is half of this and this is also half of that. So overall area will give me change in velocity. So change in velocity delta v is equal to, with sign, a1 plus a2, so that would mean 100 plus 100 minus 25 meter per second. And change is always the final value minus initial value. So this change is the final value v minus initial value u, which was 10 meter per second, and that is now 75. So we have the final velocity at the end of 30 seconds will be 85 meter per second. Thank you.